All right, I'm back. Here's the second part of the Lewis structures, dot structures, structural formula structures for today. So we just did on the previous video silicon tetrafluoride. Let's do something that looks a little bit slightly more complex, but in the end, not really. I've got 3 different types of atoms here. And so probably a good place to start is by looking to see how many atoms you actually have. So I have 1 carbon, I have 1 hydrogen, and I have 3 chlorines, right? So I have 5 different atoms altogether. Okay, next step, figure out how many valence electrons you have to play around with. Remember, valence electrons are the electrons that go into bonds, and it's the bonds that hold the atoms together. So I know that each carbon, well, there's only 1, carbon has 4, and I know that if I were to look at the periodic table, I won't do every single example in such detail, maybe the first few. Carbon has 4 valence electrons. So I know carbon's going to bring 4. I've got a hydrogen that has 1. And then, was it chlorine? Was that the other one? Yeah, chlorine brings 7. Okay, so that's where I'm getting those numbers in terms of how many valence electrons the elements, each of those atoms has. So hydrogen has 1. And then chlorine has 7, but I have 3 of them. So I've got 21 electrons contributed by chlorine. 1 from hydrogen is 22, plus another 4 is from carbon is 26 valence electrons. Okay. Now, I've got to decide next which is going to be the central atom. Remember what I said on the last video. Whichever element, right now I'm working with hydrogen, carbon, and chlorine, whichever element is closer to the center of the periodic table will be the central atom. So in this case, it's going to be carbon. Should be no surprise there. So there is carbon. Once I kind of know that carbon is in the middle, I can see that there are 4 atoms, 1 hydrogen and 3 chlorine, that need to go around carbon. Okay, so I'm going to use the dots for now. Eventually, I'm just going to use the structural formulas where I'm using dashes for bonds, but for now I can use dots. Carbon wants 8 valence electrons, just like most elements do. I'm going to put a hydrogen on the other side of one of those pairs. I'm going to put chlorines on the other side of the 3 remaining pairs. Okay, so I've placed 8 valence electrons. So let's see, that means that I have 18 valence electrons left to place on this molecule. Now hydrogen is filled, right? Carbon has its octet, which is awesome. Carbon has the 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. Hydrogen has its 2. I'll make those a little bit green. So there's hydrogen's 2. But currently each chlorine only has 2. So remembering also that chlorine likes to have a single, likes to have a single bond with 3 lone pairs, that gives me an idea of what to do. I'm going to put 3 lone pairs around each chlorine. So there's 6. There's another 6, that's 12. There's another 6, that's 12 plus 6 is 18. And I have placed all the valence electrons. Okay. If I wanted to write it as a structural formula, I would do it this way. I would take those paired electrons that are shared between atoms and I would just draw dashes, and then I would make sure to draw the lone pairs, the pairs that are not in bonds around the atoms that have them. Just because these lone pairs are not bonding to anything, that doesn't mean they're not important. And that doesn't mean you don't show them, okay? You have to. You have to show them for now. So that so that you can look and see that, yes, in fact, this chlorine has 2, 4, 6, 8 valence electrons around it. Okay. All right, let's move on to the next one. Ooh, I have 1 phosphorus and 3 hydrogens here. So this one's going to be a little different. The last 2 that I've looked at over these 2 videos have had 5 atoms altogether. This one only has 4. Okay. I know that hydrogen's on the periphery, right? Because it can only form a single bond. But let's take a look just to be sure. Here is hydrogen, way over here. Phosphorus is here. Remember, it's in the same column as nitrogen. And if you recall, I said that the carbon family, the nonmetals in the carbon family like to have 4. And nitrogen and phosphorus like to have 3 bonds with a lone pair. So let's see if that is at all helpful to us in thinking about what the structure is for. This is actually phosphine, but we can call it phosphorus trihydride. That's how I taught you to name it. But its nickname, I guess, is phosphine. So phosphorus, it's in the nitrogen column. It has 5 valence electrons. I've got 3 hydrogens. Each of them has 1 for a total of 3 there. And altogether, there are 8 valence electrons that I have to place here. So this will be a relatively straightforward dot structure or Lewis structure. I only have the 8. So I'm going to give phosphorus its octet to start. Phosphorus is happy now. And it's going to be bonded to each hydrogen. That's it. We're done. If you like the dot structure, that's what it looks like. If you'd like to do the structural formula, you would take those bonding electrons, right? You would take these and you would draw them as dashes, which I have done, and then I include the lone pairs. Again, lone pairs, there's nothing funny about, there's nothing odd about them. We see them all the time. Okay, might look odd to you at first, but you'll get used to the fact that not every pair of electrons has to be in a bond. So there's phosphine. Let's see how many minutes. Oh, we're up to 8. Oh, here, sulfur difluoride. I've got 3 atoms here. I've got sulfur. I've got 2 phosphoruses. And if you remember what I told you, the element that's closer to the center of the periodic table will be the central atom. Sulfur has 6 valence electrons. I have 2 fluorines. Each of them has 7. That's 14 plus 6. I have 20 valence electrons to use in puzzling this out. Let's look at the periodic table. Here's sulfur. Here is, I've already forgotten which halogen it is. Let me go back and look. Phosphorus. It's late. It's like 10:30. So I'm kind of drifting a little bit. All right, so we know that elements in this column like to have 2 bonds and 2 lone pairs. So let's see if we can factor that in. Sulfur is going to be the central atom because it's closer to the center. And I also know that halogens are atoms that are on the periphery because they can only form 1 bond. So sulfur goes in the middle. I'm going to put the 8 electrons around sulfur. 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 accounted for. That is, I've got 12 left. I'm going to put a fluorine on each side of of one of those pairs. Okay. And then the sulfur has an octet, but I'm not done because the fluorines do not. Each fluorine needs 6 more. So 1, 2, 3, 4, 5, 6. Another 6, that's 12, right? And if I wanted to draw it with the dashes for bonds, I would do it this way. There you go. Pretty cool. All right. Oops. I think that's going to be it for now. We're getting close to 11 minutes, so this is going to, I only have a 15-minute limit. So I have 1 or 2 others that I could do, but I will put that on the next video. Video 3, onward.